us about how we work with point clouds in Revit. And I'll speak to you about it. And so Cheyne's from Imagining. I don't know much about point clouds or Imaginers. Now all Revit learners, so I'm really looking forward to this one. And Cheyne tells me he's also going to show us a bit of Revit 2014.
Yeah, it's pretty easy.
And it's a hands-on session, so it's usually going to be jumping on the computers. Which ones, anyone in particular? Or
I think all the computers set up for it, so as long as it works in front of them.
Yeah.
A few computers to use, so sounds good.
Interesting. Okay.
Cool. Afternoon, guys. So yeah, my name's Cheyne. I'm from Imagine It. We are a Autodesk reseller, so sorry. But my background's architecture, so I studied for 5 years in the industry and then worked as well. So I studied and then I worked in the industry for 5 years. Got a couple of large companies in Adelaide, which we're from as well. So I flew over on Tuesday, so I came in on a little fancy weather, but windy weather, it was nice. But so today, we're going to go through using point clouds. I've kind of made up some sort of design brief in relation to a project, a fictitious project, and then go through how to actually set up a project, and then go through also how we're going to use sort of the point clouds in sort of our relationship, finding the limitations of Revit, and then also finding out how we can kind of harness the tool that Imagine It makes. So we are a reseller, but we also create software as well, or plugins. So the tool I want to talk about is Scan2BIM, which is a tool which we create, which kind of allows you to interact with the point cloud a bit more hands-on, and actually allow it to actually model from those points as opposed to just kind of tracing and sort of showing how that sort of works. Right. So basically the design brief I've set up is, there is a town hall that I've got a point cloud for you guys to be able to use, and you can take it home with you as well if you want to be able to play around with it. So this town hall, they've gone out there and scanned the whole thing, and we're going to actually start modelling up the interior sort of side of it, showing sort of how the limitations are. And we're going to focus on modelling out the function room, and then we're going to move into actually see how we use the just traditional tools, and then try around with some of the new tools that we've got. So who here's, everyone here's got a Revit background, or use Revit at the moment? No, no, that's fine. Everyone else kind of, no? That's all right. No, that's fine. We've got plenty.
We can hang out together.
I might even come up the back with my computer too.
No, that's fine. I'll walk through it anyway. So Scan2BIM sits on top of Revit, so it actually allows you to work inside that industry, right? Also with the whole idea today is going to go through basically the acquisition of it, so talking about how we can go through sourcing scans. So did anyone join me this morning? Excellent. Anyone else? So this morning my presentation was on actually how the workflow works, showing sort of demonstration and everything. This is going to be a very brief sort of introduction to it. So what they do is, as a scanning provider, we would go out there and actually scan the site. Right? They use this tripod on the side here, scan the building, which basically sends out a laser on the site, and then it puts stitches them all together using these targets. Right? These targets sit all around the place, and they go around, scan one area. So you see two scans here, they scan one here, and then they use a target here, and they go around to the next site and then scan it again and capture those 2 points from that same position. And then just stitch them together.
So you're scanning from multiple locations?
Yeah.
So it's only shadowing or looking around corners that we can that way.
Exactly. So what you would see, if I scan here, I'd see everything here, everything in the back side, so I wouldn't see obviously the back side of that the poster. So what they do, they scan from the outside, and then you can see as many positions you want. You just, exactly more accurate. So you're just going to scan like a stadium and try to capture the inside about everything. You get up 200, 20, 40, it really depends on how many scans you want to do. But what they do is they have these targets like this, and when it does, it scans across it and you can pick it up, and then you end up just using the stitching point. Well, these are your targets as well they use, and then just using those points to do areas.
So those are just reference points so that you can connect the dots.
Exactly.
What do you have like accuracy?
Well, as accurate as they can get it. Like the accuracy of the model is pretty accurate.
I mean dots actually. How accurate is each point?
2 to 3 millimeters.
Yeah.
Is that right?
Yeah.
Yeah, it really depends on the person who's putting it together. Yeah, you can get with it. So that's basically the process of sourcing the scans. There's a whole things to consider, alright, when you're actually going out and scanning it. Things like reflectiveness of the project, if it's going to reflect it, it's going to obviously bounce back. If it's going to absorb it, also understanding that you only can scan what it can see. So ceiling spaces, we have to start thinking about removing tiles and try to laser fit into that space. So there's a whole bunch of them. Like I said, the presenter takes them through that a lot more, but I can give that access to anyone who wants it afterwards. So what we do from that is previously in 2013, Autodesk site, we didn't have anything to be able to manage it. So we sent our scanning providers out there to scan it, and then we'd have to work with them about how many points were inside of it. So we'd have to tell them, oh, this file size is too big, they'd have to reduce the size. Or you need to tell them, oh, we only don't want everything. Now we can actually ask the scanning providers to go out and scan as high quality as possible, which obviously the file sizes get quite large, terabytes, some of them. So understanding that these files are large, so we can actually ask for that file now and actually bring it into Autodesk's program, Autodesk Recap, and manage that, right? So we can actually reduce the file size down and actually create different sort of scans of that size. I've got a little video here, which I might just play it full screen and look at that. So this is Autodesk Recap. Has anyone seen it yet or played around with it? So we can bring our scan files into this program. And then basically it does all the indexing for you. And we hit next, and we can start things about clipping it, so how many points you want to have in it, also reducing the amount of points that are coming through. So I said before, we can now capture it all. We can bring it here now, we can start decimating, which basically means reducing the number of points that are being digested inside the program. Once it runs all this, you can hit the launch project, and you end up having this 3D model which we can start working from. So this is just a scan of a warehouse that a client was using, and they wanted to work out the distances between the two beams at the top here. So they went out there and scanned the whole site, and they actually produced something like this which they can start working from. So this is all made up with points. So none of that's actually modelable. When you can see that sort of area seen before by the shadows, you can see the shadow points behind it. So you can't capture that because you can't see it. So this is what we sort of do in Recap. So we can do the decimating, so reducing the number of points. But you can also start playing around with the visualizations. So when it does a scan, it also captures photos. So we can actually overlay either black and white photos over to it, or we can overlay GB values over to it. So actually colour photos over top of it, which could actually, obviously, a lot of scanning providers don't talk about that because it increases the file size, which increases the amount of time it takes to scan or register it. But we can actually create a high visualization aspect as well. All I do is play with the tools in relation to lighting here. Also, when we're scanning it, you're going to have these sort of areas that are outside of windows, right? So it's going to scan from here, you might go out the window and capture some points across the radar, which obviously aren't of use to you guys unless you're trying to see that. So we can bring in here, we can start playing around with the section box to cut areas out to be able to export it out for. We can also come in here, we can delete points as well. So like I said, we've got a point over there, we can just select it and just delete it. So I'm just doing here, just highlight and press delete. Right, so end up having is this file, which is an RCP file and an RCS file. Alright, so the RCP file is a project file, so there's actually no data, there's only the changes you've made inside of Recap. RCS is actually the scan file, so the RCS is the large file, RCPs. Unlike the Navisworks file, NWF and NWC file. Right, so the C file is the project file, the NWF is just the viewing file, so there's just a difference between the two. What I'm doing now is just turning off the points, so you can see the visualizations of it. As you can see here, there's that ball just there, and that other ball, basically what they've used actually as targets along the side as well. So all I'll do now is saving it off as a file. There you go. So that's basically what we can do now. So we've gone out and scanned it. We've now brought it into Recap to be able to do our editing. And now we can actually bring it into Revit and start modelling from it and just using the tools there. So any questions so far?
Yeah, Recap's part of this design suite.
It is. It's as of 2013, it's free. In suites. Or you can just download it from there. So that's all free for you to access it. So we're in the studio. We've now changed it over to an RCP file and RCS file. We can now bring it into Revit, alright? So now we can look at actually modelling up this score, alright? So this is actually is what we look at, and this is actually a point cloud, right? That's not a camera view. So we've actually, what I've done, on your desktop there's a folder. There should be a folder that says handling point clouds. Right, inside it, there's a few Revit files set up already for you guys. What I've done is just gone through and used the Autodesk Revit template, right, and actually just pour that in. And we've also got inside that file some scans as well. So the first thing we're going to do is actually going to go through and link in a file into Revit. So link in that point cloud to be able to see it inside Revit to start with. So let me just open up Revit first of all. So we're going to use Revit 2014. So if everyone wants to open that up, it looks like that. The blue symbol, the blue arm. Who's used Revit 2014 so far? Anyone? Everyone used 2013? Still using that? Alright, cool. So everyone got 2014 open? Right, so when we actually create an RCP file, what we're going to do now is go up to Insert, point clouds. I've gone too fast, guys, just let me know.
Where we insert?
Open up, actually open a project first, just open up the basic template. This new project, and then select the architectural template. Just that architectural. Right, so this will be the process of just starting a basic project from start. So just opening up your template, you're typically opening up your own template in your office. So what we've got now is just a blank file, alright? So if I go up the top here, under Insert tab, under Link, we've got Point Cloud. And you just select Tab or RCP. Alright, you see at the bottom, we've only got two things I can bring in. I've got an Auto Center, Origin, all by shared coordinates. Let's bring it in just by shared coordinates and go open. Insert. Yeah. Oh, and then you go to desktop. So all the files in your desktop under handling point cloud. And then just one of those files. And then just use positioning. Origin. Yeah, that's fine. You might be miles away, it's alright.
Is that what it is? Oh, there it is.
No, you just have to. So we've got two files there, so we just bring one of them and then go by shared coordinates, then you bring the other one, you go to point cloud again, and then bring in the other one. You see down under positioning, there'll be a new one, origin to auto, origin to last place. So all I've done is gone back into that point cloud area. I'll just go to this one. And then double click. Right, and so obviously if you get this this new origin to the last place. So if you're also getting a scan of, say, a sports stadium, we're trying to get multiple scans around the area. We can use the origin last place and actually use the origin of that point cloud. So we're not actually using the origin of Revit, we're actually using the origin where that point cloud came from. Right. So switch from that and go open. We've now got this file. I should have. Scan, and it's got both scans in there. So now we can start working from here, okay? What it's done though is it's brought it in at the origin that's where it's scanned. So if I go to site here, it's going to be, well, one placed nicely at that point, but I don't think most of yours did. I think most of yours would have been placed a million miles to the top left-hand right corner. And basically that's where the origin was when they scanned it, and that's the location that they've provided. So you can actually bring in GIS coordinates of where that scan was provided if you need to.
So how do you zoom all?
If you just go to site, which basically looks over the whole project from the top, you're missing something. I don't know. What you do now is you'd go through the process of moving the origin point, right? So this is the origin point inside Revit, the center for. So we can actually go through and actually move this origin point to where it needs to go, right? I'm not going to go through that, that's kind of really management of setting up Revit. So what I'd like you to do is if you just close that file, I've got another one set up for you guys already to start with everything kind of set up. So you just close it with everything you've got there. So that's the process of actually bringing it into Revit, right? If you just now go open, and you open up Town Hall V2.0 from the same folder, so from the desktop, yeah, 2.0. It's going to come up with this open managed links, obviously because it hasn't been set up, so nothing's actually linked you back to it. So if you go open managed links to correct the problem, then go to point clouds on the top there. You'll see they're both not found at the moment. If you just go to your desktop, if you click on one of them and then go reload from, and then locate those same scans from your desktop. Alright, so now we've got our scan of our hall that we can start playing with, and it's actually set up so it's actually on the ground floor. So what I want you guys now to do is basically start creating some views of the function center for that room to the previous reload from. Once you guys start creating some views of this area, so maybe duplicate the ground floor and actually start placing some interior elevations of this view to kind of get a better feel for what this space is. So if I want to create a vertical, say, a 3D view, I can click on the little house at the top there, and perhaps the section box to be able to crop it over. So just be able to get a vertical area there. Also, I'll come around to the guys who haven't used Revit before. Yeah, that should show you better. But maybe creating some interior elevations, so view elevations of this sort of space. So really start setting up some views and sort of some sections to kind of get a better feel for what's going on in that space. So have a bit of a play around and kind of see how you go with that. There you go, thank you.
I had it before, but then I'm trying to reset it after you closed it.
I think.
I was still on the
No, it's still alright. I think he had that file open and then you just closed it.
No, I remember how to do the animation stuff, but I wasn't somebody too.
No, it's alright. Open manage links.
I must have. Oh, okay. Yeah, I missed.
Just comes flying back.
So there's the board. So you're ground floor. And that's the area we're looking at there. So all of you are placed in like elevation sections over here. Section over here. All the views in watching training sections and stuff. All the What's that? Oh, you're gonna be in how you walk and do it. So, right around floor. You see the section. Yeah.
Just sit back and look.
Hang on, that's all right. That's all right. I'm in trouble now. Don't need to look at it, no, it's fine. Okay. Oh, isn't it? The detail in the 2014 version of point clouds is much higher. They're actually placing shaders onto everything now. Before, everything was kind of a bit more meshed and a bit rude. You can see the like, level of things. See, like, you didn't just getting anything like that. So, it's all it's doing is applying. It's just a point, and then they're just overlaid an RGB value to it. So it's just like a point that is red or a point that's black, and then just have that many points that ends up creating something like that. Yeah, also. Bit to the computer, bits to, like I said, these point clouds are massive, so being able to manage that and on the area is one of the major things, really. No, that's from the objects when they scanned it. So, well, in reality, you scan an area that wall there would be slightly lighter. Yeah. Well, he does take photos of them, and that's where it is. Yeah. So,
This actually is a photograph of the materials.
Yeah.
It's representative of the actual materials.
yeah, so it scans, it creates a point of it. So, like, just in this room right now, you can scan this whole room.
Yeah.
You take a photo of that wall as well. And because that wall is white, and also has these shades, areas of the shadows, it picks up that colour and then overlays that colour onto that point. So even though that wall's all white, he understands that that area there is shadow. So that wall would actually be slightly grey where that is. How's it going? Alright, so that's how we can start creating views and start analysing that area. So you can save that, or you can just close it, and I'm going to open up the 3.0 here. So close, close, close. Open up sample version 3.0. And you're going to have to go through the process again of actually mapping in those files again. So open manage links. Everyone, go.
Which one were you?
Once you click this button here, it starts cycles through everything. That's alright. No. So, what's more? Did you click? Is this the same one? Where's it? see now I've actually gone through and actually started setting up some floor plans of the area. I've got some 3D views of it. I've also got some material elevations of it. What we're going to look at now is actually creating this wall on the top here. Right? So you see as I scan in there, I zoom in, I quickly start seeing sort of what's going on there. Right? So you can see, well I can see there's a door here. You see there's kind of a door frame going on there. I can also see that, if I zoom in here, there's sort of box shape here, so I'm imagining that's a column. So it's really, we can start working this out from this view without actually going into the other views. Saying that though, I could also go into this elevation. And I quickly see that that's the elevation of that view at the moment. And you can see there's some panelling that's going on there, there's a door. That column that I thought was there, it's trying to grey out because there's an optical wall there. But we can quickly start seeing that from this sort of description. Alright, so if I go back to that function room, what we're going to do is we're going to use just plain Revit tools to be able to actually mold this wall up, okay? So, if everyone can follow along. So from the architecture tab, build wall, and I'm going to specify the height is level 1, location line, finish base, interior, and I'm going to use just a generic wall, right? When modelling up walls to start with, if you don't know what sort of type of wall is, I would just use generic, alright? Also, perhaps you know it's plasterboard. I would typically use just a wall called plasterboard, because obviously we can't scan what's inside the wall. So I end up using like one wall's on one side and one wall's on the other side. And then if I can work out the space in between, that's typically what the stud is. Right? So you really, all we can see is what we can scan. So that's what we're going to have to kind of work with to start with anyway. Alright? So if I want to draw in this wall now, I've gone in here, just basic wall, finish base. I can snap to points. Right? Previously in 2013 it didn't like that. We just would have to line with it. There wasn't much we could do with it. If I click on here and select that point, I can drag this along. And what Revit likes to do is it likes to draw everything very accurately. Right? It likes to draw everything on horizontal lines. Right? You can see at the moment, I can see that wall is slightly at an angle. I can't actually snap to it. Right? I can place it in, I can work out sort of distance there. So if I just place this wall, I can measure the distance from, say, there to there is 31 mil. Right? That might be fine. Right? It's really up to you guys what sort of accuracy you're trying to get with these point guards, especially these point guards inside of Revit. Okay? So that's the sort of things we can do at the moment instead of Revit to work out and kind of analyse. So I'm also going to place the door. You could rotate it. So you could actually work out the angle there, and you could select that and rotate it and place the point over here, and you could work out the exact angle and rotate it from it, and you could get it there. But it's not as easy, and even then, there's no way we can access to it. So Revit, you can see that it's there, and I can see like inlines. I can see it there. I could rotate it, but if you're trying to demonstrate how accurate it is, it's really kind of. If 31 mils is fine, then that's, I know previous I worked on that, it'd be fine, it was working out a demolition plan, but we're trying to talk about trying to get accuracy of these projects. Exactly, that's what these sort of point clouds are. Normally when we're scanning things, it's because they're trying to keep this character or preserve them, or we're trying to, in addition to it, not typically scanning it like inside. So if I wanted to place a door over here, it's got a door over there, I could measure from point to point. I work out as 8 to 8, and I can place in a door. Alright, and then I could use the nudge keys, like the arrow keys, to get a nudge into position. That's close enough. I could use the arrow keys again to nudge into position and kind of get it looking right. But really, that's kind of the accuracy we can get from Revit just using the actual tools themselves. So you guys have to play around with it and actually draw in that wall. No, you could draw a line and try to do it, but it's still has those issues. Happy is great though. It should be. How you going? Just got a function here. Say that in that area. And then you just draw it. Right.
So when you hover over, you want to snap to that point. If you put tab key and go, it's fine. So you can edits and snap
Go
over.
free form.
Yeah, you can free form. With the years that one, just and then you like get that big feature of your
So Shane, how do you record inside? That's a bit
Yeah, that's because all these plots over and over again. Because they're just later. What you're doing at the moment is looking at from 1200, looking down and seeing all those points.
Right on the back out.
Yeah. And but that, see, that's kind of where the base is. So if you just go walk. So you're saying that you press tab, you can actually change, that you snap to.
Yeah, it'll snap to the point.
Okay. Just go and say, just up top here, just change it from line to another one. Then line to the other one. And then change the location line to each base 0. Yeah, and then just do exactly this. Through there. And just drag your mouse across.
So there's, okay, so that's
It's trying using a double click wall.
oh, okay, so I was really getting something.
Yeah.
I thought it was going to be
No, well that's the frame of the door at the moment, so it's 40 mils. So
Yeah, okay. So, okay, so this is
let me just scroll out.
yeah.
What we can do now is we can start. That's pretty much what we can do with Revit at the moment, right? We can kind of just kind of model off what we've got there. We can eyeball it off, and if really that's the accuracy we need for it, then that's fine. And if they're not asking you to be able to demonstrate or test it or show that sort of any further, then that's probably fine. But if we want to actually start being able to use those points and model from them, and actually select those points and now edit from them, there's inside of Revit, we need to start looking at other tools for it, okay? So from the top here, we've got Scan to BIM. And this is the product that we've created, which starts allowing you to actually interact with this file, okay? So what I'm going to go through is some of the ones I like the most, alright? So the first thing that I find is when drawing these sort of things up, being able to turn off the points on and on is kind of an issue. So we can set up 2 different views and kind of switch between the two, like one having the point cloud on, one having the point cloud off. But from here at the moment, I can quite hit a toggle, and I can just turn off that point cloud. Right, so instead of having to go to that manage links and unload it and reload every time, or go to another view, you can just do it directly from this view. Right. Also, if you've got 50, 60 scans at a site, right, and it's going to constantly try to load as many points as you can start to see. So we can go through the space here. You can see at the moment I've got 2 point clouds. If you've got 60 point clouds, you can go in here and actually turn them all off and actually save the states. So you can go in here, save states, and I can say, select the point clouds you want to see, and hit save state, and you can say, okay, they're all the ones on the east wing or the west wing, and actually go through that process of setting up sort of saving areas. Also, for visualization, we've got some stuff here, the same sort of visualizations I was showing before inside of Recap. So things like being able to see sort of elevations of points. So what we're looking at the moment is sort of analysing this point, this wall, to find out how close it is to that point. Alright. So if I move into an interior elevation view, right, there's my wall at the moment that I drew before. It's going pretty flat. I want to analyse that point to the point cloud, right? So from our analyse tab here, we've got deviation. So scan to BIM, analyse deviation. I can go deviation, I can select the face, I can pick that wall. I say I want to see the I want to test points within 5 mils of that, 5 centimetres of that face. So either side of it, I want to actually analyse those points. If I bump it up so it's actually testing on as many points as possible, you can update here. what it's going to do is it's going to place a colour over top of all those points. So if I just quickly turn off that point cloud, and if I just change do not copy, alright, you can see here at the moment, all the points that are cyan, all this dark blue colour, are within 0.0 mils and 0.25 mils, right? So if that sort of accuracy is fine, then we can quickly see from this sort of diagram that it is, right? You can also see at the moment that there's obviously these sort of dark colours. So that would tell me that there's obviously a bulkhead up there or something that's going towards the side. Also, there seems to be this sort of change going process we saw before because the wall is a slight angle. Right, so we can see it kind of fading up there. And also it says there's a line that goes on there as well, so it's telling me that it stops at that point. Right? So we can quickly create some sort of diagram from here and move back into like a circle right now. Now we can see it actually needs to stop. Or it needs to stop. We can drag it down to put in the data and I've moved down it properly, but we can quickly see from the sort of diagram that I can work these sort of things out.
Can you reanalyze that to be improved?
Yeah, so if I go now, just hit clear, so it's going to basically, so clear basically gets rid of that analysis on it, and I can run the same test again, so deviation, hit base, update. Right, so you can see now it's only testing that part of the wall. Does anyone have a good shot at that? Play with that. So that was the function room north wall for the interior relations. So you got to send it. And then you want to go to deviation. Keep the ice. It's basically testing the amount of points that are along the space. So you just change it to 5. That's right. Change it to 5. And then go pick face. You need to pick face the wall. Okay. Oh, sorry. Just change it to 5 again. And just bump it up to top. Update. And then just toggle and turn off the point. Okay, just hit one here. That way. You can't see the little symbols because the do not drop use BIM. You don't know that one. Yeah, you just hit toggle. You basically turn off the point button. And then you just come down. You just move. Just click do not copy. Okay, next one. Okay. There we go. Doing it. Good sense or? Alright, so that's how we can start analysing it, okay? There's a few other analyse tools under deviation. Things like we can start seeing it, create histograms, so we can see like a graph to be able to demonstrate to someone, or we can also show sort of you can export out to an Excel sheet to be able to show exactly how many points along that space. Right, so I don't really want to go through too much, but that's kind of what, there are deviation tools to be able to demonstrate and show to someone how close this point, this model is to those point clouds. Right? What I want to go through now is actually modelling directly from it. So if I go into northeast wall here, right, so we've got this wall here. So this is what I'm going to do. So I'm going to model this wall here, but instead of actually going to my floor plan and just drawing along that, I can come up here to, once again, scan to BIM, create wall region growth. And all I do is I click on that point 3 times, so click once, twice, and 3 times. What it does is it triangulates that wall, those points in that triangle, and then it analyses it and tells me along that face, you can see at the moment, so the plane face is 0.02 degrees. Basically, it's telling me that the wall is pretty much straight up and down. Right? If the wall's at an angle, you're working with an older building, you would say maybe 3 mils, or lift shaft if it's 3. Or, so we can actually start creating a wall directly from those points. And we can say at the bottom here whether it's going to be a mass wall, so a mass wall allows you to actually have a wall on angle, right? Or we can create a profile wall, it's going to draw a wall straight up and down, right? Also, we can have appearance that wall type, so I'm once again just going to choose my generic 100 mils. Also interior. If I go to create profile wall, it's going to create a wall directly along that space, right? So give that a shot. So go into your east elevation, and I'll show that. So just jump into your. So yeah, I did. Just go to east. What? Yeah, just do the same thing. Yeah, just wall region, right? Just wall like this. I want to keep this wall. Yep. Yeah. So and then just choose what sort of wall you want to get. Yeah, so I think you might have selected something else. You might have been like something on the wall. So important. So how did it go? No dramas there? Alright, so we do the same thing again. If I want to actually test the sort of performance along the area to find out. So you see how quickly I can model that. If I literally just run that same deviation check again. Pick base. So you can quickly see sort of how that wall is actually functioning and what actually is going on. So you can see at the moment, all these walls here look pretty right. They're within.
How did you get that colour?
This here.
Located?
Here can one of you, crop view, or do not crop view. So you see at the moment that all these points in that area are pretty accurate. And then obviously it comes over here and starts stepping away. And there's obviously something in this area here. We see at the moment in that view, there's a window there or something that's having an issue with. We can.
So when it creates a rectangle, it doesn't create a shape.
No, you do. It'll actually stop. So if I ran a wall along, say, space here. No, it'll find all the points up that space. So it'll create a one up that area. But then if you were trying to work out sort of the shape going along there, you have to work into an interior elevation view, and you have to work out how it's cutting. So, what else can I talk about? Do we have any MEP guys for it? Fine. Is this fine? Alright. I'm going to open up it. It's pretty easy to show this through a video, just because I don't have one at the moment. So this here is a So this is a pipe room that was just gone out and scanned quickly. So it's basically the workflow that we do with it. So we can do the same thing. This same workflow works for columns and also for circular columns and also rectangular columns. It also works for working out MP sort of duct runs and stuff like that as well. So it doesn't work with just circular ones. So all I'm doing here is just creating a work view, a 3D crop plot of the area I work with, right? So we don't want to see. We only really want to focus on the area you can see, right? So if I was going to say create this pipe run that runs on here, I'd make sure that everything in the background here was turned off. Also things like that, because as soon as you start, what we end up doing is we actually do circles for a rectangle in the areas we want to create. So all I'm doing here is just creating a rectangle on the space, and it analyzes and actually works out all the circles, all the points around the circular space, and that's it there. And then we just use typical sort of Revit tools to create a pipe from it. So you can see there's a line that's running through, and that's the pipe. If I've got that selected and then do the same thing again, it creates another pipe directly from that spot. It's aligned with here, and it creates another pipe. So it actually just puts them both together. Right, once again, let's do the last one here. And do the same thing. Select those points, search. Same pipe tools. Create pipe. So you see here, they're all pipes that are spread. All I'm doing now is I'm using normal Revit tools to be able to trim together. So trim. And that's basically how quickly we can actually create a pipe run of that space. Directly aligned with those points. testing.
Do you have flange templates?
No. It basically uses what's actually built into Revit P Ready. So all the sort of fittings that are inside of it are purely the ones that have come out of Revit. So he doesn't know how to align it. Because obviously Revit is so, there's a lot of parameters applied to it, but it applies to placement. He doesn't know, he doesn't actually create the extra flanges himself, he actually just uses the ones that are actually in the template. Or that you guys currently have in the template.
So you have flanges in templates?
Yeah, most offices that use MEP would actually have those sort of things in there already. So it uses the same sort of modelling elements that are already inside the program.
To use this to scan as built, can you do an analysis between cloud without actually modelling it there, just comparing that to the design model?
So you
So you've got
model
the
something
model,
out.
and now you point out, you bring the point out, you align it, and a bit of deviation.
Yeah, we're the same. Yeah, exactly. That's the deviation before the testing. If you have modeled something out, then you go out and scan it afterwards.
Yes.
You could run those same tests and then actually say how much you want, how far they are away.
So you can just put it, so the trick is just to get a line down in the model so get it close to alignment.
Exactly. Last one I show is topo surfaces. Alright, so I know that you're going out there and surveying something. Yeah, last thing. If I hit topo surface here, there is a topo surface tool at the top which allows us to actually create a topo surface directly from those points. So this is a house we've got here, and this is all grass. Right, so all we've done is just gone out and scanned it all. And all I did is hit topo surface, clicked on one of those points, and it's basically analysed all those points along the space. So all I'm doing now is basically applying grid to the whole space and saying test for a slope allowance across the side of each grid. So you quickly analyse and get all these points that actually fit the criteria. And then create topo surface at the bottom here. Leave it for 4 minutes. It basically creates a Revit topo surface directly from this point without actually going out there and getting a survey. Alright, so you see there's the topo surface. Really accurate. Obviously too accurate some of it, so you can see that some of it's jumping up and down. So there's my topo surface. See how accurate it's being on it. We can click on that and just use simple Revit tools to start kind of eliminating some of that. So we've got simplify surface. I can select that and basically turn down the accuracy, basically remove some of those points to be able to actually get something that's not this giant mass of points.
So when you scan that from ground,
Yeah.
so the accuracy is okay.
So it scans it and it'll actually pick up everything. It will actually scan anything you can see except for the area directly below itself.
But it's intersecting with the ground at an acute angle. The accuracy might be an issue, but you should across the board.
Yeah.
Yeah, of course, yes. You shot it from a lot of points there.
How many courses do you shoot?
That one there? That one there was 12.
12.
Yeah, that was 12. That was 12 scans earlier.
What about the other one?
That was 2. 2, yeah.
How long does it take to capture?
Scan? It varies, like depending on how many scans. Like the scan before of the, what did I showed you guys? So that house there, it took half a day to be able to go there. So we ran it for half a day and scanned it. And it took us about an hour to be able to actually stitch them all together. And it took about half a day to be able to actually bottom up that.
Yeah, so the camera too, is it the scan? The ability to scan?
To be able to do it.
The actual capacity to scan. How many points you can scan?
Yeah, so there's different sort of scanners you can get as well. So some we can just capture a lot of data. So if I was going to be scanning MEP data, like pipe, we want it more high intensity because there's a lot more points which we're analysing. But if I was just capturing, say, just this base before, I really only need enough to be able to see how it's along. So,
Well, scans are the next scans.
this Trimble, Ferro, Leica, this
It's just the usual suspects.
yeah. We've got programs out as well. They have their own programs that you can actually start modelling from inside of things. But if you're currently using Revit and trying to actually model inside of there.
So that's what you use for the top?
Sorry?
What camera is, what scan you use for the top?
No, doesn't matter at all. The more points you can actually test on, better. But even that, wouldn't recommend scanning topo surface too often because obviously grass and the levels of it.
Yeah, if you've got a lot of long grass.
Yeah, and that's obviously an issue. But if you're scanning like hard surfaces,
But if
hard
you
surfaces.
get elevated, you get down, what about putting it up on something?
it's still going to capture what you can see. So there's long blades of grass, it'll hit that. If you can get through, if it gives you something accurate, but I wouldn't be saying that the accuracy level you needed. I know that.
And the hairdressing station scans often buildings.
Yeah, it's in stationary. Also, if you're trying to scan trees and stuff, just trees sway, so this is really pretty useless. So it's really good at, scanners are really good at capturing like hardscapes, like walls, bridges, buildings, but as soon as you start talking about moving data, it has a bit of an issue with it. Cool with that?
Cheers, Mike.
Thanks, guys.
Thank you. Thanks, Shane.